You're sharing some presentation. Can you check whether it is working?
Yeah, so should I start?
Yeah, you can
Yes,
share this.
I'll stop sharing my screen.
You stop sharing the banner and then let him try sharing his screen.
Yeah. Give me 1 minute. Just trying to.
Go for the slideshow mode.
Is my screen visible now?
It's visible, and you can go to the slideshow mode.
Yeah, I understand. 1 minute. I am also looking at one more slides.
I think Kishore Sujata is not joining.
Yes, sir. Sujata madam is not joining. Can I start? With this?
1 minute. Professor, just I have one query before we start.
Yeah.
I think the flash quiz is to be administered after your first part of speech, isn't it? After the first. So during that break, we'll administer that flash quiz, which Kishore has already loaded.
Yeah.
And after that, you will continue.
Yeah. Yes.
Okay.
Yes. Okay, sir.
Okay.
We can start, sir.
Yes.
Kishore,
good afternoon, everyone. I'm Kishore from PALS Program Management Office.
This meeting is being recorded.
Welcome to PALS 32 practice lecture. Now I would invite Ramasamy sir, PALS champion, to welcome the speaker and introduce the speaker.
Good afternoon, everybody. Good afternoon to the Professor Dr. Ashish Kumar Sahani, my own colleagues in PALS, all the students and professors. So I hope you are all energetic and ready to receive from the session what the professor is going to share with us. Today, it is the second of our T2P lecture for this year, and we have with us Dr. Ashish Kumar Sahani, who is a professor at the Department of Biomedical Engineering of IIT Roper. So we are fortunate to have him. Professor Sahani is a man of many parts. He is a professor as well as an entrepreneur. So this year's theme is, in PALS, as you all know, is think like an entrepreneur. Whether you are in a job or wherever you are, that's how you have to think. So this session is falling under the theme. Professor is heading the Medical Devices Lab, the Biomedical Engineering of Institute of Technology, Roper. And he has a PhD from IIT Madras and postdoctoral training from Harvard Medical School and University of Michigan. He brings to the table a vast amount of technical know-how, starting from the level of bare metal electronics and low-level firmware to machine learning, web development, and virtual reality. So you can see that it's a multidisciplinary experience he has got. And then he teaches course on electronics, software design, medtech, and business. He is the founder of Epilepto Systems, a BIRAC-funded company working on software and wearable solutions for management of epilepsy. And he is also the strategic advisor to many deep tech and health tech startups. This year we have got, again last week we had AI and in healthcare. So now it is now clear that today the medical profession cannot do without engineers. So you can all you can see that many of the sessions are going into medicine. So this is yet another thing. And professor, he has touched lot of areas. So he will touch the theory and he will touch the practice, and he will also talk on entrepreneurship. He will summarize his journey of building end-to-end medical devices and software solutions, employing wide-ranging skills from the disciplines which I mentioned, and then also about the different products and wearables that he has developed. And then he will talk about his entrepreneurship journey. So I request all of you to make good use of the opportunity and be interactive, and let it be a very learning experience. Thank you, and over to the professor. Thank you.
Yeah, thank you, Mr. Ram, and thank you to the whole PALS team for having invited me to this to deliver this talk. I see that a lot of people have joined. Almost more than 400 people are already online. So this is a large.
Also
scan.
streaming on YouTube, sir, for your information.
What?
Also streamed.
Streaming in
Also streamed in YouTube additionally to this, because this
Okay.
hall can take only 500. So we have streamed it in.
The YouTube. Okay, so seems like a very big gathering. Yeah, so it's an honor to be part of this, and probably you guys are located at Madras, I see, and Chennai is quite close to my heart because I have spent 5 years at IIT Madras, and I have done my PhD from there, and kind of I then started learning Carnatic music also because I got interested in Carnatic side, although I'm from Orissa. And I have done my BTech from Kalinga University in Bhubaneswar. And after that, I did IIT Madras PhD. And after that, I was there for 2 years in US. And then since last almost 5 years, I am here at Punjab. So kind of I have got experience all over the country from complete north to complete south. And so now I kind of understand India better, I feel sometimes, because of my experience with multiple states. Okay, so coming to our presentation. So I thought that as most of you are probably engineers here, and I myself have started my journey probably from a tier 2 college, from a private university, in fact. So I understand that many of you who are from private universities many times feel that, okay, whether we will be able to make to those places where those who have undergraduate from IITs would be able to make. And probably I am one example who could, reach beyond what initial opportunities I had through my BTech. And it's all about how you make yourself, how you create opportunities for yourself, and you try to make good use of the opportunities that come in your way, and that way you will be able to reach anywhere. And it's not that your current education or where you are right now is going to limit you. So if I look at my journey, so I have done my BTech from KIIT in 2010. After that, PhD from IIT Madras. Then I had a postdoc experience at Harvard Medical School and University of Michigan. Then I joined as a assistant professor at IIT Roper in Department of Biomedical Engineering from 2018. I then have went on to found almost 3 companies. So one company, Epilepto, is I am a co-founder in that. There are 2 other companies which I'm quite closely involved with, Neontrum and Magnimus. and all of them are in health technology space. I was also the faculty in charge for and director of technology business incubator of IIT Roper. So that way I have helped a lot of companies or startup companies, basically startup companies created by students in their initial few years to help them, stand on their feet and even raise fundings worth multiple lakhs to crores. So that way, I feel I have, quite a lot of experience now in both product development as well as entrepreneurship. Now, when sometimes I feel like how this experience in product development and interest in product development came about, I actually see the roots of it in my engineering days. So during my engineering, I was very interested in both hardware as well as software. So even in my end of my 12th class or around my 12th class, I used to write these software for at that time there was this language called Visual Basic through which you could program software uh, for Windows XP. And at that time, even mobile phones and computers were not that prevalent. Means they were there, but mostly it was accessible at internet cafes, and internet was not as easily available as fast internet as you are probably used to. These kind of internet were not there. So even learning about robotics, we used to go to say internet cafes and learn, okay, how to build a certain robot or how to program microcontrollers. All those learning I did probably by going to internet cafes and downloading whatever material could be done at that time. And I learned to program. I was very fascinated with programming. In fact, I had taken in my 12th, 11th class, I had taken biology. And then I dropped it in my 11th, at the end of my 11th and 12th, I took this IT as the subject. And at that time, I could write programs of 5,000 lines long. I could write virus programs, which will copy from one pen drive to another automatically. Like when you put your pen drive into your computer, it will copy into itself. All those things I used to do. Although probably ethically, they will not be considered quite correct. But at that time, it was like fun to do. And so I learned a lot of basics of programming during those times itself. And when I entered engineering, I entered into electrical engineering because I thought, okay, computer science seems very easy because I will be able to, I'm already able to write such good software. So let me learn electronics. So then that's why I went into electronics. And in electronics, I was very fascinated on robotics. So these are some of the robots that I had designed at that time. If you see, and we had competed at various IITs. Like this one was at IIT Madras at that time, and we had won at IIT Madras at this was an image processing robot. In IIT Bombay, we had also won at that time. So although from perspective of sitting where I am today, it probably appears like not very big achievements to do. But at that time, coming from Orissa and trying to and winning at these IITs where other teams from other colleges or the IITs would be there, and we could beat them, was something which was very fulfilling, and it gave us that confidence that yes, we can also do what people at IITs can. So after that, yeah. So after that, I went to IIT Madras for my. Actually, I joined for MS at IIT Madras, and but then I converted to a PhD. I didn't do a MS. I actually did a PhD, integrated PhD in some way. So there my primary work was on development of a device to measure arterial stiffness. So arteries are generally, if we see human arteries, they are elastic in nature. So when blood flows through arteries, like when your heart pumps, then the arteries are elastic and they expand and contract. And if your arteries are more elastic, that means they are more healthy. And as atherosclerosis, which is a deposition of fat and proteins inside the arteries walls, they increase, then the arteries start becoming stiffer. And it is a natural process with age. But if people are not exercising and if they are eating too much fatty foods, then the aging of the arteries can be accelerated, and there can be faster atherosclerosis, which can then lead to higher stiffer arteries. So stiffer arteries means for the same amount of pressure within the arteries will expand less. So current methods of measurement of arterial stiffness use expensive beam or ultrasound imaging systems, which are bulky, expensive, and are non-portable, and they require the services of a trained radiologist to operate them. So we designed a device which was a portable one, which used just a single element ultrasound transducer to send ultrasound pulses inside the neck where we have the carotid artery. If you touch your neck both sides, you'll be able to feel the pulsation of that carotid artery. So we took this ultrasound. This is a single element ultrasound transducer that we created, and we used to fire it 50 times a second. After each firing, we will receive one frame of ultrasound, and this is a single line ultrasound. This is called as A mode ultrasound. There is no image in this. So if you are placed right across the arterial diameter, then we will have two echoes, one from the proximal wall and one from the distal wall. And these two echoes can be visualized in this animation as you see. And the algorithms that I developed, they could identify if you are correctly placed on the carotid artery, because if the transducer is not placed correctly, then you will not be able to measure the arterial stiffness, or you will not be able to get the carotid artery in frame. So first task is to be able to identify that the probe is directed correctly. And second, once the probe is directed, then approximate locations of the proximal and the distal walls are identified. And then they are tracked with time to obtain the distension waveform, which is the diameter change waveform, because as the arteries expand and contract, the diameter expands and contracts. And this is called the distension waveform. By measuring the total change in diameter for the total change in pressure, because your heart, basically the pressure is continuously changing. When heart compresses, the pressure goes up, and when it decompresses, then the pressure goes down. And this happens continuously. Every time you hear this sound, lub dub, that's basically your heart compressing and decompressing. And every time the heart compresses, the pressure in the arteries goes to the systolic pressure, which is the higher side of the pressure, and then comes back to the diastolic pressure. So, and that in turn leads to expansion and contraction of the arteries, which are captured in this distension waveform. By using this formula, which is total change in pressure divided by total change in diameter multiplied by the inner lumen diameter, or the end diastolic lumen, the inner lumen diameter, we can measure the elastic modulus, which is the measure of the arterial stiffness. So the algorithms that I had designed, they could identify the proximal and the distal. They could identify if the frame has carotid or not, and then identify the proximal wall and the distal wall of the carotid artery and track them to obtain the distension waveform. So when we did the testing of the device in our lab, we could get the measurements quite accurately. So then when we started taking the device onto field and started doing it in hospitals, then we found that in some cases, it will give a waveform which looks reverse to the one that is expected. The expected waveform for the distension of the carotid artery is shown in the red curve here. So when we took it in the field, sometimes we saw that the distension waveform reversed. So this is where, when you go and do research, many times what you have observed in your labs may not match what you are doing in the field. And that's what gives you a learning experience and you then come back to drawing board and try to understand why it is happening. So then we went back to lab and looked at, okay, what might be causing this. So we studied the anatomy of this zone of the neck, and we identified that besides the carotid artery, there is a femoral artery. There is a jugular vein. This jugular vein is a vein which basically carries the deoxygenated blood back from the head and neck. Now, this jugular vein pulsates in the reverse in a out of phase manner with the carotid artery. If we see the B mode, this is the ultrasound imaging modality, and here you can see the carotid artery and the jugular vein. So here you can see the carotid artery and the jugular vein. So when the carotid artery is expanding, the jugular vein is contracting. And when the jugular vein is expanding, when the carotid artery is contracting, the jugular vein is expanding. Okay. So if we now correlate that with what we received or what we observed in the ArtSense device, we see that if by mistake the transducer is somehow targeted at the jugular vein, and this phenomena only occurs when the patient is in supine mode. Like when the patient goes supine means when the measurement is taken when the patient is in the sleeping position. While all the experiments that were conducted in the lab, in that the patient or the subject was in the sitting mode. So in that mode, the jugular vein does not pulsate. While when the patient goes supine or is sleeping, at that moment, if we are doing the measurement, then the jugular vein fills with blood and it starts this pulsating behavior. And so as the most of these measurements were done on field by the doctors, so they would prefer that, okay, patient goes supine and we do that measurement, and that would lead to this kind of error. So once we understood this, then we designed another set of algorithm by integrating a 3-lead ECG into our machine. So ECG waveform looks something like as shown here in the black curve. ECG is the electrical activity of the heart. So as we know, electrical activity travels much faster than the mechanical activity. Mechanical activity is basically the pulsation of the artery. So when the blood reaches here, so when the heart pumps, before the heart pumps, there is an electrical pulse, which is the QRS complex or the R peak shown here, which is sent out from the heart. So through QRS, through ECG, we can identify we can measure that when the heart actually was instructed to pump through the R peak location, and then we obtain the distension waveform, and through that we know that you can see that the pulse arrives at the carotid artery after the R peak has been fired. Basically, heart starts pumping and then the blood takes some time to come to the carotid artery. Now, once we plot both the carotid artery and the jugular vein simultaneously with the QRS complex or the ECG QRS complex, then we can use that QRS complex to create a threshold of both the waveforms. And the jugular vein, the carotid artery spends most of the time above this threshold, which is this black line, while the jugular vein passes most of the time below this threshold, okay, which is this black line. Another thing which happens is the carotid artery expands faster while the jugular vein expands slower, and carotid artery contracts slower. Carotid artery expands faster and contracts slower, while jugular vein contracts faster and expands slower. So by measuring the slope of both of these, we can then distinguish if the distension waveform is of the carotid or is of the jugular. Now, this solved the problem of distinction between the carotid and the jugular vein, and it could then enable us to measure the carotid artery and not be confused with the jugular vein. But while doing this, we also added one more feature to the device, because now we can also measure the jugular venous pulse. And the jugular venous pulse is basically, jugular vein is connected to the right side of the heart. So if there is any problem with the right side of the heart, will also be reflected in the jugular venous pulse. So this was initially a problem, but when we actually did more research to remove that problem became a feature. Yes.
Sir, the screen stopped sharing.
It stops here. Okay.
Now it's okay.
Okay. So what I was saying was that a jugular venous pulse, which was creating confusion in the beginning. Once we solved this problem, then we could measure the jugular venous pulse as a separate waveform, and so the carotid, the jugular venous pulse, which was initially a problem, became a feature. Now we could measure the problems, or we could identify problems with the right side of the heart using the same device. Okay. Now another, so once we did that, then towards the end of my PhD work, then I was thinking like there is something which is called as the carotid to femoral pulse velocity, which is like the carotid artery pulsates when pulse blood moves from heart to the carotid artery, and then there is a femoral artery which supplies blood to the lower part of the body towards the legs. And so if we can measure the carotid to femoral pulse velocity, it is known as the something like that this is the gold standard of arterial stiffness. This carotid to femoral pulse velocity is known as the gold standard of arterial stiffness. So initially, so this is the way it is measured in in a patient. So carotid artery, one measurement is done, and then using a pressure transducer, it is typically done. So here the doctor is putting a pressure transducer to the neck of the patient, and the carotid pulse is obtained. After a while, then the femoral pulse is obtained, and then using the ECG, the pulse velocity is measured. The femoral pulse is something which initially we thought that probably is not possible from our sense. But one day while I was sitting in my lab, then I directed the probe at my femoral artery, and I could actually get the femoral pulse. I could get the femoral arterial echoes, which were not as clear as the carotid artery echoes, but we could get it. And so algorithm could actually track the femoral artery and could obtain the femoral arterial pulse. And now that we have an ECG, now we integrated the ECG because we had the problem of jugular vein. But once we integrated that, then the possibility of measuring the carotid to femoral pulse velocity also opened up, because now that we have an ECG, we can integrate the ECG with we can measure the pulse transit time from the heart to the carotid artery, which is basically the time distance between the R peak and the foot of the waveform of carotid arterial pulse, and the jugular venous pulse transit time, which is the time difference between the ECG R peak and the foot of the jugular venous pulse. So using these two pulse transit times, we can use a formula which is given by this, and we can measure the carotid to femoral pulse velocity. So this enabled the measurement of carotid to femoral pulse velocity, which is known as the gold standard of arterial stiffness in ARTSENS. So this project was kind of closed when not closed means it is still being continued at IIT Madras, but my work on this I had concluded when I completed my work there and came back. But very recently, I looked at if we can apply machine learning on the same problem and then see that if there is any performance improvement. So this is where I revisited the problem almost 4 years afterwards using the same data that I had collected during that time. And very recently, we could design machine learning models. So these are neural networks that we designed, which could identify the carotid present versus absent in a frame with more than 99% accuracy. And we could also measure the inner lumen diameter and measure the distension, basically the diameter, with accuracy of less than, or an error of less than 0.7%. So the performance improvement after applying machine learning was almost 10-fold. Like it was 10 times better than all the methods that I had developed during PhD. So which were the traditional signal processing methods. So we see that using machine learning, many times the advantages that we can gain with respect to traditional methods is very high. And they can achieve same performance or much higher performance with much less effort, because they can learn very complex relationships which can be difficult for human beings to imagine and program. If you have enough data, then machine learning can do many times better modeling of a problem than humans can do. But if you have less amount of data, then human beings probably can do better job than machine learning. This is another interesting problem that then I was doing at University of Michigan, and then we are continuing this kind of work also at in my lab. So ultrasound, as we know, is known as an imaging modality. You generally do imaging with ultrasound, imaging of tissue structures within body using ultrasound. But very few probably would know that ultrasound can actually be used as something like a finger, like an invisible finger, to push tissues inside body without actually opening up or creating an incision on the body. So this can be done by focusing the beams of ultrasound at a particular point inside the body. So nothing in the pathway will be pushed, but the point where you are focusing, that point will be pushed. And another way ultrasound can be used is for ablation. Like you can basically burn off or heat tissues inside the body and can create ablation. So this can be used to, say, ablate cancer or tumor inside body. So this, so using the acoustic radiation force, which is this focused beam of ultrasound that is used for pushing the arterial surface, we thought that can it be possible that we design something that will be able to measure blood pressure by using ultrasound. So the idea was that we will push the arterial wall with a beam of ultrasound, and because arterial wall is under stress, because there is a pressure inside artery, so that's why the arterial wall is under stress. Like if you have seen tablas, walls are under stress, and then if you hit it, then it starts vibrating, and the vibration frequency depends on the stretching level, like how stretched the surface of the tabla is. Similarly, we can imagine like the arterial wall is stretched, and if we hit it with a beam of ultrasound, then the artery will compress, and then it will rebound back and it will start oscillating, and the oscillation frequency will depend on the pressure within the artery. So we thought that we can probably create a reverse model to be able to measure the pressure within the artery by measuring ultrasonically measurable parameters, which are the diameter of the artery, the thickness of the artery, and the vibration frequency after hitting it with the pulse of RFE. So for this, we did a lot of simulation first, because it is not possible to get a lot of arteries or a lot of tubes of different diameters, different thickness, and different elastic characteristics. So when you have limitation in physical, getting physical models, what you can do is you can create simulated data and simulated models as computer models. So there is a software called as COMSOL simulation software, in which we can design these kind of tubes and specify different diameters, different thickness, different internal pressure, density of the tube, elastic modulus, tube length, and then we can modify this. Like we can continuously change different tubes and then try to simulate the vibration of this tube. So if you can see that we basically simulated with these number of parameters, and if you do a combination of all these parameters, the number of simulations are more than 58,000. And in each simulation, we get different vibration modes, like a tube can vibrate in multiple ways. So these are some of the vibration modes that are shown here. We are interested only in the hoop mode image. We are interested only in the hoop mode image, which is shown here, and that hoop mode vibration frequency. So that was identified through image processing from all these images that were obtained. Then we developed a machine learning model that could take diameter, density, thickness, and the hoop mode frequency to measure the internal pressure. And here's where we could obtain an accuracy of, or an error of, less than 5.5% for measurement of the pressure within the tube. We then created, we also did experimental simulation, experimental verification of our model. So here you can see that we have ultrasound probe, which is directed at an arterial phantom. Arterial phantom is basically a model of the artery. So there is an elastic tube inside this this material, which is called a gelatin. So gelatin is basically pig skin's powder. Okay. So, but when you put it in hot water and then do some processing, which is not very difficult, hot water, then stirring, then waiting for some time, and then letting it to cool for some probably one night, then you can create a structure which is almost like tissue and muscle. And so it will have similar consistency and it will appear like that under ultrasound. So we embedded a tube inside this gelatin material, and then we could create pressure externally inside the tube, and we could swing that pressure, as you can see in this picture here, that we can change the pressure in the tube, and we could take it through a sinusoidal variation. And then each time, at different time points, we vibrate the tube, and you can see the vibration frequencies of the tube at different time points. And if you are able to see, the frequency basically goes up as the pressure goes up, and the frequency comes down as the pressure comes down. So the frequency has a relationship with the internal pressure. And then we verified it with the ML model that we had designed using the simulation, and we could get an error of about less than 3.6% for the models that we had developed, even experimentally. So this kind of combines, or was able to verify, we are able to verify our modeling work with the experimental work. And most of the research that you do is, many times you develop a model, you do some theoretical work, and then ultimate test is whether your theory is matching with the experiments that you're doing. And that's where we are very happy that we could actually achieve very similar results in both theoretical simulation as well as experimental verification. One of my student, a PhD student, is working over this mercury-free sphygmomanometer. We have been working on this over last 4 years now. So mercury is known to be toxic to both humans and environment. But mercury sphygmomanometers are very popular all over India. They are generally banned all over in developing countries, but in India they are still quite widely used. But there are 3 different types of sphygmometers which are available in market: mercury sphygmometer, aneroid sphygmometer, which is a spring and dashboard based sphygmometer, and we have the automatic BP monitor, which is a oscillometric type. Ultimately, mercury sphygmometer is still considered as the most accurate device. It is being banned not because it is having any problem or any accuracy problems. It is being banned because mercury is considered to be toxic. And India is a signatory to the Minamata Convention. And before that, so we actually did a survey among Indian clinicians. We asked them that which of these is the most accurate BP measuring device. 80% people, or 80% of the doctors, consider that mercury sphygmometer is the most accurate device. And then which one is the most robust? Again, mercury BP monitor, most of them consider as robust. And this was a kind of a market survey. So whenever you do or you develop a product, you want to do some initial market survey so that you understand that whatever product I'm going to develop, whether that product is going to have any market acceptance or not. Just starting to develop something without understanding the market, is generally not a good idea, because ultimately you have to find out that whether this final product will be accepted by market or whether it will be sellable or not. If it is not, then there is no point in wasting time in building that. So this was kind of that survey that we did. So India is a signatory to the Minamata Convention, under which India is obligated to remove mercury sphygmometer. So one question that we asked, that if we build for you some sphygmometer or a BP monitor which is very close to mercury sphygmometer and operates on the same principle of operation, will you buy it? And 90% of doctors said yes, we will buy that device. So this kind of gave us the confidence that yes, there is a requirement in market for this device. And so let's go ahead and try to build something like that. So we developed another material which was a alloy of, it's an alloy which we developed. It's a metallic alloy which has properties very similar to that of mercury. Now, what are the properties of mercury that makes it suitable for sphygmometers? Anyone in the audience? Anyone knows that what's the properties of mercury which make it suitable for BP monitors? Yeah. Yes, so mercury is quite heavy. Okay, it's a heavy liquid metal. Okay, what is the density of mercury? Anyone knows what is the density of mercury? It's 13 kilograms per 13 kilograms per liter. Okay, so it is 13 times heavier than water. And another property of mercury is that it does not stick to glass. So if you put mercury anywhere, it will just jump there. It will not stick to anything. So these are the two properties which make mercury spirometer very suitable for making blood pressure monitor, because something which is heavy, liquid at room temperature and does not stick to glass is required. So the material that we created, that actually is half as heavy as mercury. Its density is about 7 kilograms per liter, and it is liquid at room temperature. But one property which it didn't have is that it sticks to glass. So then we worked a lot on developing another chemical which goes as a encapsulation on the chemical that we developed, or that alloy that we developed, which then could make it non-sticky with glass. And so this is the testing of that device side by side with mercury. So you can see, as our device has density half that of the mercury, which is on the right, that device, that material only goes up by half the amount as that of the mercury. So mercury rises double. Our device, which is on the left, it rises double that of the mercury. So because it is half as dense. But it is still acceptable, because one of the advantage is that now the visibility of the numbers is more, because now the difference between the two numbers or the two readings is double that of the mercury. So it can give better accuracy in terms of not doing rounding of errors, which most of the clinicians are prone to, like they round off to the nearest 5 or nearest 10. So in our case, the rounding of errors are minimized. And in the clinical setting, the height of this spirometer is still not a problem. And we have filed a patent on this, and this is the device that was designed. We also did clinical trials of this over 260 patients at Dayanand Medical College and Hospital, Ludhiana. And the error with respect to mercury spirometer was less than 8%. This paper was recently published in Nature publications scientific reports. This is the product from my startup, Epilepto. So Epilepto is my first startup, which is working on developing solutions for patients of epilepsy. So patients with epilepsy have this problem, like they suffer from seizures, like this uncontrolled shaking of body, hands and legs for few minutes to few seconds, and that's what characterizes epilepsy. Now, epileptic patients can lead a normal life by having continuous caregiver attention. And so whenever they have a seizure, if that seizure can be detected and somebody can be alerted, who in their caregiver or in their family, then they can we can avoid injury and death of patients many times. So we have been funded by BIRAC to develop a smartwatch that would be able to detect when the patient is having a seizure. So in this smartwatch, we will have 4 different sensors primarily. One is a skin temperature sensor, a heart rate sensor, a accelerometer sensor, and a EDA sensor, which is for EDA sensor is for measuring sweating. So whenever the patient is about to have a seizure or is having a seizure, at that time the skin temperature goes up by a little bit. They have shaking of the body, and some of them have, some of them do not. And there is a heart rate. The heart rate of the patient goes up, and they also have sweating, which is to be captured by electrodermal activity sensor. So this is the smartwatch design that we have made, and you can see that in the smartwatch design we have whenever you design such complex electronic circuits, so this is a very complex electronic circuit design. This has 2 layers of PCBs, and each PCB has 6 layers within it, and there are huge number of components within them. There are 2 microprocessors on the main CPU board. There is a display. There is a BLE or the Bluetooth. There are 32 MB flash. There is a USB programming, USB charging. So all these have to be built around in a very small footprint. And in the sensor board goes below it, there is a battery and there is a vibrator motor, and everything has to be packed within 4 centimeter by 4 centimeter, 4 centimeter footprint. So in this kind of design, we typically use software-based PCB design softwares. We first capture the schematic, like the circuit design is captured, then the design is transferred onto a PCB routing software. In that, the routing is completed. Then most of the times, probably in engineering, you will only study how to make components or how to use components on a breadboard. But ultimately, when you go to industry and you are making an industrial designs, you generally work on complex designs only on computers. You then send it out for manufacturing, and there are specialized manufacturers who can then manufacture all of these boards, all your designs at a very small SMD level. So these chips are very small, and you cannot manually solder them. They will have to be soldered many times using machines on assembly line, and very fine soldering technique as well as machines are required to do them. In addition to that, smartwatch, Epilepto has also developed a multilingual app for self-management of epilepsy. So this is an app designed for patients with epilepsy. It supports multiple languages, multiple Indian languages. It has a digital seizure diary in which patients can record their seizure activity, like when they had a seizure, they can record that. It has an anti-seizure medication reminder. It has a medication reminders which will give push notification, because taking medicines at right time is very essential to live a seizure-free life. So patient can enter the medications that they have to take, and it will give a push notification every few whenever the patient has to take the medicine. At that time, it will give a notification to remind them. It can also create a SOS call. So by a single button, the patient can create a phone call to their caregiver, as well as send the current location of the patient to that person, who probably can then come to their rescue. It has a lot of informational videos and content on epilepsy, and it supports multiple Indian languages. It has a chat bot in which patient can chat with that bot regarding general conditions of epilepsy, general questions on epilepsy in their own languages. And it has been built with extensive feedback from neurologists all over the country. This is a device called Foot Pulse that again another of my student is working on. This device is designed for patients of drop foot. So these patients are suffer from those patients who have stroke. They many times lose the functionality of lifting the front part of their foot, and so they then have a abnormal gait cycle, and then when they're walking, the front part of their foot slides on the ground. So for that, we are developing a wearable device that can be strapped below the knee of the patient, and it has a machine learning model built onto it on the edge. So when the patient is trying to walk, it will detect that the patient is trying to lift the foot, and there is an electronic circuit inside it which will stimulate the peroneal nerve. So peroneal nerve is the nerve that supplies the electrical signal from the brain to the lower part of the foot. And because the electrical signal is not coming from the brain, so once we detect that the patient is about to lift their foot, we will stimulate it externally through the foot pulse device. So it will create a pulse of 100 volt peak to peak, or about 70 volts peak to peak, and will be able to then stimulate the front part of the foot. So here you can see my student Vijit, using this device. So when he is trying to lift the front part of his foot, you see it is automatically stimulated and the front part is lifted. It is appearing like he is doing it, but actually the device is able to stimulate the foot and the foot is lifting up. So again, a lot of machine learning work has went into this. For collection of data for machine learning, this was a rig that was created. So whenever you are doing machine learning work, you will also need to collect data, because machine learning only works most of the time. Most of the machine learning models work by some kind of supervision based on real data that is collected. And so here we have a underfoot sensor, FSR sensor, that we had attached for during the collection of the data, so that we collect the ground reality of when the foot has actually lifted and use that for our modeling purpose. In COVID-19, we had done a lot of innovations around COVID-19. So this is a ventilator that we had designed. So this uses an ambu bag, which is at the center of it. Ambu bag is a bag that is used for manual ventilation of patients under ventilation, and those who are suffering from pneumonia. So we use this ambu bag at the center of our design, and then we created these robotic arms on both sides. So these arms are driven by a belt kind of mechanism, and this belt, so we have these arms mounted on the belts, and we have 4 stepper motors on either sides of this ambu bag on the 2 walls of the ventilator. And then this stepper motor can be controlled very accurately to compress the bag and deliver the exact amount of air that is required by the patient during the breathing cycle. So here you can see my one of my student Mohit operating this ventilator. It was designed with a full touchscreen display, and there is a Raspberry Pi, there is a Jetson Nano board, which is a single board Linux computer running this, and it also has an Arduino board that is controlling the stepper motors. It controls, it can control pressure, volume, breathing rate, inspiration to expiration ratio, PEEP, and oxygen levels. And it supports all major modes of ventilation, including assist control mode. It has a battery backup of more than 2.5 hours, and it can be used in ICU, as well as it is portable enough that it can be transported, used as a transport ventilator. It also has a battery pack inside, so it can operate without power for almost 2 hours. So in the second wave of COVID, we saw that there was a huge shortage of oxygen cylinders, and many people died because of shortage of oxygen. So that time we developed this device, which we called as AMLEX. So this was designed in a way that that we realized that people on oxygen therapy require oxygen only when they are inhaling oxygen, and during exhalation, oxygen is not required. But most of the time, the oxygen, because the oxygen is continuously flowing through the mask, and these masks are porous masks, so oxygen is getting leaked out during the exhalation. And inhalation to exhalation ratio for humans is typically 1:2. So that means more than 2/3 of oxygen is getting wasted when the patient is using, is on oxygen therapy through these oxygen cylinders. So we designed a system by integrating a humidity sensor within the mask, which will detect that when the patient is exhaling, the humidity level within the mask goes up. And there's an electronic circuit which automatically determines, okay, the patient is trying to exhale, and shut off the oxygen supply. So there is a powerful valve which has been created, and it is attached to the oxygen cylinder. It can be controlled electronically, and you can see that when the patient is exhaling, the valve is closing down, and when he is inhaling, the valve is opening up. And through this, we can save 1 in every 3 cylinders. And this was covered widely in media at that time. This is a smart pillbox that we have been developing in our lab. So it is a design in which we have circular chambers which can store up to 7 days of medicine at 4 different times. So this circular chambers can be rotated, and these circular chambers again have circular PCBs at each level. So on the 4 bottom, in these 4 layers, there are these 4 circular PCBs, and these PCBs have IR LEDs and detectors which will be able to detect if the patient has taken the medicine or not. It has a lot of smart features, including water tracking, tracking if the patient has taken medicine or not, vibration-based alert to the patient, like whether the patient has taken, so alert to the patient, like if the patient, to remind the patient like they have to take the medicine at this time or not. that it is also has a Bluetooth and Wi-Fi connection in it. And it is battery powered with 1000 milliampere hour battery built into it. This is a product that the second startup of mine, Neontrum, is developing. So we have neonatal cases, or the babies which are born before their time of 9 months. So they typically spend a lot of time just lying immobile on beds, and these babies are very small and their skin is extremely thin. So what happens is, if they are lying on the bed for a long time without moving, then they are prone to developing something known as pressure ulcers. And these pressure ulcers can be point of infections, which can lead to further development of infections in the baby and potentially be fatal to them. So we were in talks with our clinician collaborators, and they all wanted that if we can develop a solution for that, such that we have something like adult. For adults, we have anti-pressure ulcer beds in which there are alternate channels of expansion which expand and contract, so that the pressure points are continuously changed below the body. Similarly, they wanted if we can develop something which is of which can be useful for babies, and that's where we developed a this anti-pressure ulcer bed of very small size with multiple pressure channels, so that the babies need not be rotated multiple times by nurses in order to reduce pressure ulcers. So baby can lie without the nurses needing to change their position continuously. And this will reduce the workload of nurses as well as improve the care of babies towards reduction of pressure ulcers. This is a very exciting product that we are developing. This is a startup that I am closely advising. So this is a startup which named as Magnimus. You can look at their website, magnimus.com. And in this, we are developing a product in which we will be able to transform you into the metaverse, where your physical body will be tracked and your motion will be transferred into a virtual character in the metaverse. And you will be able to either get into a AR-like situation or a VR-like situation. For example, on the left side, you can see my student Mohit, who is wearing a VR headset and is able to experience a VR experience, or a completely immersive VR experience, where a 3D character is able to follow what he is trying to do. And so a lot of machine learning modeling has went behind it. In addition to that, a lot of game development through Unity, and it's a very complex project, and it's currently something which is underway, and probably this product will be out in next 2 or 3, maybe by next month, and probably some of you can also experience it by playing it at that time. Yes, so that's all from my side for this session. I'll probably talk a little bit about entrepreneurship if the time permits. But if there are any questions for this part of the session, you can ask. Thank you.
Thank you, sir. We have a question from a professor from KPR IET. I'll post the question in chat box. You can answer, sir.
Yeah. Yes, someone has asked that I'm really suffering from foot drop for last 4 years. I may get foot lifter that will be helpful for me to lift the foot easily. Also, whether the system will cure the foot drop further, please let me know. Yeah, so so this device right now, the clinical trial is pending. So maybe in 1 more year, we are aiming that this device can come out into market. There are actually some other devices which are available in market. There is something which is called as, which is a type of shoe in which you can put your foot and it will keep your foot live. I think you might already be knowing that. it will always keep your foot like this, but it is not very comfortable, I believe. There are some stimulators also available internationally, but those stimulators are probably a little bit more expensive. So hopefully we will have something out and probably we'll be able to help you at that time. Is there, if there is any existing technology to transmit and receive signals from hardware to human organs or human nervous system? In fact, the foot pulse device that we are developing, in that we are in fact stimulating the peroneal nerve, which is going inside the your legs. So we can actually receive the signals from electrical signals from inside the body and sending electrical signals inside. Both of them are possible. There is no problem with it. In fact, I can show you one more example of which one experiment that I did in my as a lab that I teach. I don't know if let's see if is my screen still visible.
Yes, sir, your screen is visible.
Yeah, on my website I have put up one experiment which we had done. So I had taken this cockroach leg. So we had extracted some cockroach legs, and then we put 2 electrodes across the nerve of this cockroach leg, and then we stimulated with we took a oscilloscope and a signal generator, and we inserted this. Is my screen visible?
Yes, sir, we can see the video.
We can stimulate this with a square pulse from a signal generator. 1 minute. Yes, so as we increase the square pulse frequency, you will see that we are able to stimulate the legs of the.
I'll increase the frequency to 5 beats in 1 second.
So 5 beats in 1 second. If we do, you see 5 times in a second, it will kick.
5 beats in 1 second. Okay.
Yeah, so hope that answers you. Okay, any other questions? I'm putting this link here so anyone interested can look at that experiment. Okay. So if there are no questions, we can move further.
Shall we have the flash quiz?
Yes,
Kishore?
we have.
I think Sriram V has raised his hand.
Yes, Sriram only asked the question in chat box.
Okay.
That has been answered.
Okay. You can go for the quiz, flash quiz.
Okay, madam. Okay, dear participants, we now have a flash quiz. My teammate Manigandan will post the slider quiz link in the chat box. You can follow the link and log in. I'll share my screen.
We'll answer that question, Muktar, after the quiz.
Sir, can you stop presenting your screen, sir, so that I can host the quiz? Thank you.
Present. Wait.
Link is has not posted.
They can also scan the QR code and join.
Students, you can log in using the link posted in the chat box. It is a timed quiz. We have each question you have 20 seconds time. So be quick to answer.
People should register fast.
I think Manigan has left the chat. I think left the meeting.
Right? Why are you telling that?
No, I want the link to be pasted in YouTube also.
The thought it is only in the end.
We can wait till 300 participants. 230 has joined the quiz.
$400 வரைக்குமே போகலாம். 491 இருக்காங்க இங்கே. So,
Okay.
can you check? I'll check with.
Okay, 300 has joined.
Mani has joined.
We can start once it reaches 350, madam.
Yeah. Are you sure it has not reached the YouTube, guys? Because
Sure, somebody is raising the hand. He has named himself.
Link. Okay,
Yeah,
I'll
yeah.
paste the link. Okay, madam. We can start the quiz.
yeah, yes.
Okay. I'm going to start the quiz. Question number 1. Okay. Many of us answered B. The answer is D. Second question. Ultrasound can be used for. Okay.
Good.
– 400 participants are attending the quiz.
Okay.
Okay.
Oslo.
Yes. Okay. The final question. Okay. We can now see the leaderboard. These are the top 5 students who got answered B quick. Shruti Rajagopalan. I don't know from which college you are.
He's got all 6.
Yes. All 6.
Devasena, I think it's from KSRCE. if I'm not wrong. Good, yeah, very nice.
Okay. Okay.
So let's go to the second part of this.
I think one more question is pending. Sir, if you want to answer the question now or after the session too, sir.
That regeneration using that pig material. Asked
Yes.
a question on, let's say, about the gelatin and and how it is used for regeneration. Talked about some tissue, pig's
Yeah.
tissue powder.
Question, 1 minute. The question
Fine.
is,
Mokhtar Ahmed. Could you please explain about gelatin?
yeah, regeneration. Yeah, gelatin is not used for regeneration. It is used for developing tissue phantoms. Tissue phantoms in the sense like something which mimics the tissue in terms of its physical and ultrasonic characteristics. So this is basically pig skin's dried powder. So when we put it inside so the way we do it is we take that powder and mix it in water with say 5% gelatin or 4% gelatin for example, if you take 1 kilogram of water, then you take 5% means 50 grams of gelatin and mix in that and keep stirring it slowly and put it inside a microwave oven for some time. then bring it out, stir it again, mix it. So like that you do until it is thoroughly stirred and homogeneously mixed, and then put it inside a fridge for one night. And the next day when you bring it out, it will appear like it appears like tissue, and it also appears under ultrasound like tissue. It's used for testing.
It is only for research purposes and not as a substitute inside somebody's body or something like that.
Yeah.
I think
Okay.
we can go to the second part.
Okay.
Yes, sir. You can start the second part of the session, sir.
Yeah. So is my screen visible? Yeah.
Yes, sir.
Yeah. So as I am quite involved with multiple student startups, and I think in today's world, only what to say, the traditional mode of getting a job and getting a fixed salaried job is something which is still quite commendable, and probably most people would like to have that. But the opportunity of developing your own venture and opportunity of making fortunes through that um, pathway has opened up, and a lot of these opportunities are there in terms of both the infrastructure that is available today, the connections, um, the information on how to build things, and also a lot of money is available in the market, both in terms of private venture funding as well as government support to build your own ventures. And if we go through this pathway, we will be transforming ourselves from being job seekers to job creators. And this is a pathway which is also very fulfilling and challenging. If you are able to develop a product which is able to go to the market and a lot of people are using it, and you will feel like, okay, I have been able to really contribute something to the society, and in turn you will also be able to make a lot of money, which in a traditional job you will not be able to make that kind of money, which probably if you are able to develop a startup, if you are able to develop a successful startup, which is definitely a more risky proposition to do, because not many startups succeed, but those who succeed, they can make a lot of money. And in fact, recently we had this Shark Tank India, which has kind of grown the interest of many people, even people or your parents who were not earlier aware of startups probably have become more aware of startups if they have watched the Indian Shark Tank. So how do we build a startup? So there are few things which I think, although I teach a complete one semester course on entrepreneurship, and so there are few things which I think are the core to it. And rather than explaining, so we'll probably not have time to explain everything, but at least some parts of it I can, some important concepts I thought I can cover. So first step in building a startup is probably to make your team, make your core team. And the core team, when I talk about core team, there are multiple different types of team members. The most important team members are your co-founders. Co-founders are the one who are kind of the shareholders of your company. So when you start a company, you want to say, have somebody whom you trust and somebody who can bring onto table a complementary skill. For example, if you are very good at electronics and you need to develop a product which requires both electronics and mechanical engineering, then you can get a friend of yours whom you trust, or probably who is very close to you and also knows mechanical engineering, onto the on board as a co-founder. And a co-founder is not just somebody who brings onto a skill. There's a lot of personal rapport is also required, because that person will basically be taking the risk and he will also be building the company along with you. And when you are building a startup, the initial years can be very tough, because your startup will not be making money in the very initial years, and you will need somebody who can stick around with you, even if you are not able to pay their salaries. Can they be able to be besides you and keep building and keep hustling with you? And that's what is the role of a co-founder. And I believe while you are in your engineering college, it's the best time to build a startup, because once you are out of your college, a lot of other pressures will start impinging you. For example, you will be asked to say, you will start getting pressures of getting a job, getting married, and other things, which will make it more difficult for you to build a startup. So while you are in your second or third year of engineering, if you are looking at an entrepreneurship career, then probably you should try to find a co-founder amongst your batchmate or amongst your friends, and then try to build some product or which you both are excited about, and start building. So that's the role of co-founders. Now, another thing about startup is when you start about thinking, okay, what startup I should build, the first thing will come to you, okay, what is the product that you'll build, or what is the service that you'll give? So basically, what is that idea that the startup will go after? And initially, may think that, okay, I have no ideas. And then when you start thinking about, you might have a lot of ideas. Okay, you might have, say, 10 different ideas. All of them look like, okay, we should do this or do this, and all of them look like, okay, these are doable, and these will also be relevant business ideas and probably profitable business ideas. So it can become difficult to freeze a particular idea that you will go after. So there is a chart that I many times suggest people to use. It's called the PUG concept chart. So the PUG concept chart is like 1 minute. It is draw that for you. One minute to tell you. So it is like, if you are not sure, and if you have 5 different ideas, what you can do is you can draw a chart like this. You can put on this side idea 1, idea 2, idea 3, like this. Okay, put like this. And on this axis, you put items like, say, how much money it needs, how much money is required to build this product. Do I have the skills? Do I or my co-founders have the skills? How much demand is there in the market? So these are some of the examples, but you can go on filling this. Okay, go on making multiple entries in this table, and for each entry, whichever entry you are thinking is the best entry, for that you put 0. Suppose idea 3 is the entry that initially you're thinking is the best entry, then put 0 for that. And after that, if idea 2, then you evaluate, okay, with respect to idea 3, in terms of how much money is required, is idea 2 more money is required or less money is required? If more money is required, I will put -1. That means I don't have that much money, so I will put -1 for that. And idea 1, if more money is required, I will add, if less money is required, I will add 1 + 1. And similarly, you can do for all the sections. So +1, -1, like that you can do. And in the end, you add all of this and see the score. So the baseline idea, which is idea 3, will be 0. Everything else you will get, you initially expected that idea 3 is the best. So everything else should have come out to be negative. Okay. But if any idea comes out to be positive with respect to idea 3, that means you had a bias towards idea 3. And actually, when we try to do it objectively through this PUG concept chart, we find that this idea 4 actually came out to be higher. Okay, so through this you can, this is not only suitable for this case, there are many other, for example, you're trying to develop a product and that product has 4 different designs which you can go after. You can follow a similar process to find out, okay, which design is better or which design you should go after. Okay. Yeah. So after you have frozen the idea, then after that, you should, before building, one thing you should do is try to get some customer service, because initially you might have some idea, but if you don't know that whether the customers will like it or not, then it's better to try getting to as many real customers as possible, or as many potential customers. For example, if you are building, say, for example, this drop food device that I spoke about, if we are trying to build it, we should probably go to those patients, try to find out patients who drop food, and ask them, like, do they want such a device, or what is the problem with the current devices that are using? Are they using any current devices? So have a kind of interview. Even if you do this interview for 10 people, 5 people, you will get a broad idea of whether this product will go anywhere or not. Okay. And in the customer survey, if a product is not looking like it will make it will be liked by customers enough that you will be able to create enough revenues, then it probably at that stage itself you can stop development rather than going towards the development. Once your customer survey shows that yes, the product has a potential, then you can start building the prototype. Okay. In fact, the customer service is also required because many times I see, like in research labs, we develop a lot of things, and most of them are developed without any feedback from the actual customers or actual users. And most of the products or most of the devices, like, we first develop a nail, we first develop a hammer and then go about the world searching for a nail where we can hit it. Okay. The thing should be other way around. You should find out, okay, oh, there is a nail which I have to hit into the wall. Okay, then I need a hammer. Then I should develop the hammer. Not that you first develop the hammer and then go about finding a nail to hit it on. So once you have the customer, once you Mr. Ram, your audio is, yeah. So once you develop a prototype, once you are sure of developing a product by doing your initial due diligence in terms of concept chart, and then then through customer service, then you should build some prototypes rather than trying to build the full product in one go. Try to build very simple prototypes. The prototype can be as small as, for example, if I'm trying to develop a phone, prototypes can be of different types, or depending on what you're trying to test. If you're only trying to test, say, the ergonomics of this phone, like whether how heavy it will be, whether this weight is fine or not, and whether this form factor is fine or not, you can even take a block of wood and design it and create the design of appropriate weight without any functionality. The only functionality it has is weight and dimension, and then put it in a pocket and roam around for a few days, and you will get an idea that whether the customer will like this form factor, whether they will be comfortable with this weight. You can even give that prototype to a few people and then ask them their feedback on it. So this is a very simple prototype without having to develop any electronics, any displays, and you will be able to get some feedback on whether this form factor is fine or not. There are more functional prototypes, like you develop a part of the design rather than, for example, design just for the display without having any internet or any, even SIM card in that. So, and develop your design step by step. So that through that you will be able to, there is something which is called the lean startup. Lean startup process is where you develop one feature at a time. And many times you develop 2 features and you send one feature to one set of people and another feature to another set of people, and find out, like, okay, this is called as A/B testing, like which feature is more acceptable to the customers, whether A feature or B feature. So depending on the feedback from the group A and group B, you'll be able to freeze that. A similar process can also be done for software prototypes. Software prototypes can be like simple drawing on paper, where you design the user interface just on paper, and then give it to a developer to develop it further. You can even use more fidelity, high fidelity UI designs using softwares such as Figma and Photoshop. And ultimately, you can even develop partially functional prototypes by only coding parts of the interface without developing the full interface. One important aspect of startup is hiring the right people. So when you are starting up, you may not have enough money, or you may not have a lot of money to hire very expensive talent, or from say hiring IITians or hiring somebody who is very experienced. It might be difficult for you with the money that you have. So at that time, you have to see that, okay, where can I get people who are less experienced but have the potential, who can be able to do the work that you are looking at, even though they might require a little bit more training than a experienced guy will be able to do immediately. So hiring the people with right temperament is more important than hiring people with great talent. So even if, so whenever I have to hire, I will look for talent, I will look for their accomplishment, but I'll also look for their temperament and also their fit into the culture of the company. Because if they are very talented, but they are always looking for, okay, this is just a temporary thing, I'll quickly complete and I want to move out, then it is not very useful for you as a startup. You might want that, okay, somebody, even if he is having a lower rank in their exams or have a little bit less marks, it's fine. If they have better, if they are more dedicated, they will be able to learn, and if they can stick with you for some longer time, probably they will be able to gain the expertise that is required to build your product. And ultimately, once your startup is able to raise more money or is able to get more revenue, you can then make them slowly more permanent with you. Funding is, of course, one of the most important things in startup. A startup cannot survive without money. In fact, any company cannot survive without money. And so initially, you will have very little money. There are different pathways through which the initial startup can be funded. The first round of funding can come from which we call as bootstrapping. Bootstrapping is you use your own money through your own savings, or you ask money from your friends and relatives. So you try to be as frugal as possible, use as little money as possible to come quickly to your first prototype, first demonstrable prototype, which you can use to acquire few initial customers, even though the price of the product is very low. But if you are able to show initial traction, if you are able to show a product market fit, like there is a requirement in the market and you have been able to acquire few customers who are willing to use your product, then an investor will be more interested to put in money into your product. If you just go with an idea and ask for money from people or investors, they will not be interested. Your friends and family might trust you and may give you some money, and that's what you can use probably to start building. But to get external investment, you will have to show a viable business model by acquiring few initial customers, and showing some initial traction. But if you are able to show some initial traction, currently there is a lot of investor money which is available. People are willing to invest in products and in startups which can show exponential growth. Currently, a lot of money is actually available in software-based startups and IT startups, because the scalability of these startups is very high. You can scale from 100 customers to 100,000 customers very fast, and using you don't have to increase your resources by 10 times. Okay, you will not have to increase your resources by 1,000 times, but you can increase the customer base by 1,000 times. So that's the advantage of many of these IT startups. But IT startups are also competitive space, because technology moves faster and a lot of people, other people can enter into that space quickly. While hardware startups have a high bar of entry, you will have to, there is a difficulty in entering that space. But once you are there, then there is less competition also on the top. Ultimately, in the end, you have to also look at sales and marketing. Sales and marketing is a aspect which most of the engineers forget about. But after a while, after you have developed your product, and after 1 or 2 years when your product is in the market, you will see that sales and marketing will become bigger, will take a larger chunk of your money and larger chunk of your time than your actual product. And sales and marketing, if I give you an example, for example, if you are developing, say, a game on Android, now that game, people should know about that game. Then only they will be able to, come to you and download it. Most people will not search for your game. So they have to see that through ads. So you'll have to give ads in, say, Facebook or LinkedIn or somewhere. And that ad, for each click, LinkedIn or Facebook might charge you, say, 50 rupees per click. And so your customer acquisition cost, like to get a customer on board, you might have to spend, say, 100 rupees to 150 rupees. Now, will you be able to recover double that money or at least that much amount from the customer in few months of their usage? And will you be able to retain that customer over the long term? So that's why there is requirement of developing sales and marketing channels. Developing sales and marketing channels, for example, you can start developing right away. Even when your startup is right now not active, you can develop your sales channel through, for example, be active on social media, post on few things. So there is a startup, Yoboshu, that I was guiding for some time, and they have been able to raise a venture capital round, and they have now moved to Bangalore. So they are a health tech company. And I found, so they have a very dynamic founder. Her name is Shivanshi. So she's very active on social media. So she keeps posting. Now she has become a social media influencer. She has about more than 100,000 followers in her profile. So what helps? How does it help her startup? It helps her in a way that now she does not have to use a lot of money to do that kind of advertisement. If she has to advertise something, she can post it through her account, and 100,000 people will see it immediately. So that is free advertisement. So if you are developing your social media presence, then that can also lead, in a way that you will be able to increase your visibility, increase the visibility of a product, and you'll be able to reach out to a lot more people for a much less price. Yeah. So this is, I think, these are some of the ideas that I wanted to discuss on startups. The floor is open for questions. If there are any questions that you would like to ask me on startups, I'll be happy to take it.
Meanwhile, during the registration, we got some questions, sir. I'll post the questions. I'll present the questions. You can answer, sir.
You can stop sharing the screen and Kishore will start sharing.
1 minute. So this is my, I'm posting my,
You have stopped sharing, so.
I have stopped it. I'm posting my LinkedIn profile link here in the chat box.
Okay.
Those who are interested, they can connect with me through that. Yeah, so the questions here, how to choose effective technology for product development and implementation. Okay, so effective technology, it depends on the product. Like whatever product you are developing or you are looking at developing, first, it's probably a good idea to find out what product you want to develop. And it is not essential that you need to know the technology beforehand. Many things which I develop today, even for example, this game that we're developing, we didn't know game development earlier. We first figured out, okay, this is the thing that we want to develop, what is required to learn it. And we found that, okay, we need to learn Unity, we need to learn Node.js, we need to learn, running machine learning on browsers. So all that we started learning step by step as we went forward. And today's day and age, what happens is you have a lot of free resources available. If you go to YouTube, you probably can learn anything that you want, free of cost. People are there who will teach you. All you need is a discipline to, follow a pathway and learn. And so that way you will be able to find a technology and as well as learn that technology to develop a product. How to get mentoring or support for an idea? Yeah, mentoring, like many times we actually do not approach people. That's a bigger problem I find, because people think that either they do not reach out to people because of their ego, or because they feel like, or the fear of rejection in the sense, like if there is a professor or somebody who has a big company, and you think that, okay, if who am I to go and ask them? If I ask them, will they give me even any time? Many times you don't realize that these guys who are accomplished also want to contribute back to society. And when you actually talk to them in a polite way and actually tell that you need help, so many of them are actually happy to give you, say, say half an hour of their time to give you some mentorship on how to go about. And once you ask their advice and reach out to them, you will see that they can open doors for you, which otherwise you will find very hard to reach those doors. So I was reading somewhere regarding investment. It was saying that ask for money and get advice, and ask for advice and get money. Okay. So if you go to someone and ask for money, they will give you advice. Okay. And advise that, okay, why this product will not work, or what we should work on. But if you go and ask them for advice, they may say, oh, once they give advice, they feel like they are building the product, which, yeah, the ownership comes in, and then they might feel like, okay, I should invest in that. Okay. So next one is how to improve the quality of products that have boomed in the current technology. Improve the quality of products that are booming in the current. In fact, if a technology is currently booming, that means a lot of people are already working on developing the product. So it's a good thing when a lot of people are competing to develop a product, because competition is something which leads to faster development cycles. When a technology is not having competition, then product development slows down. How to convert ideas into products without a lot of capital investment? Yes. So here the question is, you try to first identify how much capital is required to develop a product, and you realistically try to gauge that how much money you have, or you can bootstrap from your parents or family, or can you get some government grants or some kind of grants through which you will be able to get that kind of money. But government grants are unreliable in the way, like they can take a long time to process, and there is a competition to get them. You may or may not get them. So thinking like, okay, I will get this grant definitely, is very difficult. And once you get that grant, also for that money to come to your account might take you many months. And startups today move very fast. So if you are waiting for some money and somebody else has the money, they will develop it faster than you. So the way is to think realistically, like which product can I develop with minimum amount of money, or the amount of money which I can afford. And that's where I find like those who are in their studenthood, going after software startups or IT based startups is a good idea, because that kind of product development you can do with very little investment. And after you have developed and raised some capital using that, through that product, and have gained experience in entrepreneurship through that, then you can go into more capital intensive product development. I give the example of, say, Elon Musk. Elon Musk's first startup was Zip2, which was very close to something, which was similar to something like Google Maps, but using text. And it was a software startup. He initially built that product and then sold it for a few $1 million. Then using that money, then he developed X.com, which then was merged with PayPal. Again, another software-based startup, which was a banking software. Then using that, he was always excited about space technology and about fast cars. So then he went into developing these two companies, the Tesla and SpaceX, which are extremely capital intensive products. But he could not have developed it right away in the very beginning. So what he did is he developed other products, then made that money through which he could then develop these capital intensive products. How to choose to work on a new product, how to predict the market. This I have already explained in the PUG concept chart. So you can use the PUG concept chart to find out which product to go after and whether that product will sell in the market or not. Again, there are certain, if you want to see where the direction of the market is, there are some reports which come out every year. You can, there is a report which is called as the, I forget the name of the report. It comes out every year. It tells about the technology trends for that year and which technology are in the upswing and which technologies are right now in the downswing. It is, I will find that.
Gartner reports?
Yes, Gartner technology report. That Gartner report you can go through. You will get an idea of which technologies are currently upcoming and which are going down. If a student is interested in becoming entrepreneur, what should he look out for? Well, I have already explained few things in the entrepreneurship lecture. What are the major technical skills a biomedical engineering student should have? How to become a successful entrepreneur as a biomedical engineer? Okay. So any kind of biomedical engineering product, as I see, mostly require mechanical engineering, electrical engineering, and computer science. There is a bit of material science also which is required at sometimes. Okay, but if you know about if you are good at any two of these fields, you will definitely be able to develop good medical device products. So I would suggest that you try to focus on developing skills in any 2 or 3 domains amongst these 4 or 5 that I said. Okay. And entrepreneurship as a biomedical engineer. So there are one thing is talking to doctors, talking to patients is very important to understand what is required in ground. Don't just develop something which there is already a product there, or there is no market in there. And second is, if you are trying to develop something which is a class 3 device, so there are different classes of medical products. So as an initial entrepreneur or as a biomedical engineer who is trying to build something and you don't have a lot of money or time, you want to build something and send it to market as soon as possible. So work on class A products. Don't go into class B, class C products initially, because then there is a lot of regulatory aspects which will slow you down. So once you have experience in building a class A product and delivering it to market, then you can probably look at class B or class C products. Is there any resource that gives ideas to build products for different market segments? Well, if the idea is already there, then somebody will already start working on it.
Start thinking, boss.
Yeah. Thinking in the sense
observing and thinking will help.
Reading a lot, and reading what is the current state of the art, and if you are already on the state of the art position, then you will be able to see where the directions are, and you will be able to push that boundary. Yeah.
Professor, somebody has asked what is class A and class B.
Yeah, class A devices are the ones which, for example, if you are making a smartwatch, okay, which does not go inside the body, it does not interact with the inner chemistry of the body, neither it is doing any invasive thing inside body. If you are developing an app which is able to scan your iris by using a phone camera, that is a class A product. Okay, so anything which is only used on the skin, but not either on the skin or outside the body, and which is not interacting with the inner chemistry of the body, which are generally considered safe, and you do not require too much bigger clinical trials, or you do not require approvals. Okay? Okay. So then you will be able to do that faster. Otherwise, you will be spending a lot of time and money just taking approvals and going through clinical trials.
I think a lot of questions are here. are asked before the session, which already you have answered in the session. So
That
that's
is
another
okay, but when I have asked a question, I would like a specific answer also from the speaker. Luckily, we had the time, and
Okay.
it was very well paced, I should say. Shall I go on to propose the vote of thanks, Ram?
Yes, madam. Yeah, yes, madam.
Kishore, yeah, thank you.
Anything
Yes.
else, Kishore? Okay, okay.
Yeah, thank you so much, and enjoyed the session. Glued on to my seat,
Yeah.
and a lot of things came a lot clearer. Like we have this lab to market work group in PALS, which works on a similar area. Like what is it, from research to the market or a lab to the market and things like that. Made a lot of sense, and we have a couple of competitions also that run. So all these things are so relevant. It's like I'm in the right supermarket to collect all the information that I need. And your articulation of the arteries and the CVDs and food drop was so much relevant, which as a champion I could relate to it. I have seen some patients like that and things like that. And every item that you talked about was simply very nice, and it was from the heart when you said we start with what we can do and then go to what we aspire to do. So that is a great philosophical thing that people should understand, because nothing comes free in this world, and we have to work towards a specific ambition that we are running after. So it was a wonderful quality time that I spent here, and I'm sure all the students enjoyed the session and got a lot of points to ponder, rather than just jump into something. Even if it's a startup, how do you do it in a paced manner? How do you get there and uh, do it in a structural and process oriented way, rather than just jumping your puck charts, concept charts? Everything is just the tip of the iceberg, and I would suggest all the students to go back and look up your Google search or whatever, because I know most of them don't go to the libraries. They only search, and pick up all the keywords that he said, the professor said, and we will be able to get more information and we'll be better people. And the idea of the theme being think like an entrepreneur also is very well served by this talk. So I think it is a complete package which summarizes PAL's activities for the year. And I would love to have a continued contact with you, Professor, for our other activities as well, because we are connected with about 32 engineering colleges in and around Tamil Nadu and outside India as well. So you will be a great guest for us for several of our other things, an entrepreneur conclave or anything you fit in, just like that. You are there, and you're also our own alumnus from IIT Madras. That adds to the parameters as well. So thank you so much, and thank you all for being there. I know your bus is waiting for you, and thank you all for a great session.
Anu, I would like to add thank Vikram,
Right. Sorry.
who got on to Dr. Ashish in the first place, and because he is very busy, he is hard to get. And at this juncture, I would
I know.
tell that Anu wants to use Dr. Ashish in a lot of ways. I hope we can get in touch with you, Doctor.
Yeah, sorry, I told we probably found it a little difficult for to contact me.
No,
but I had the things in mind. I knew that okay, I have to deliver it.
Yeah, but both the time.
No, we will do it. We will do it, Ram. Not an issue.
Everything came on time, but I was getting across through Vikram, so I'm just saying that Anu will.
No, I will reach out to him. I already tried the LinkedIn. It wouldn't come up as yet, but then I will connect with him in the LinkedIn, and then
email is fine. I saw your email. I just I was not aware of this kind of format and giving these questions and answers. I thought
that is okay. That's okay.
That's
always
a
first time.
And we thank you. You have done it very well. Yeah.
It was wonderful, and I really enjoyed the session.
Okay.
Thank you.
Thank you.
Thank you so much.
Thank you, sir.
Thank you,
Kishore,
and thank you, Vikram Bhaiya, for being with us. And we need your continued support from Hyderabad as well. He's connected with the IIT Hyderabad wing, Vikram, and I think we will have a continued support. And I saw some of my colleagues here, CNC, Arun, maybe, and all the PMO members who had been supporting us in this activity. And a couple of faculty members who asked the right questions as well. Thank you very much.
Thank you, ma'am.
Thank you.
Kishore, you can close the session.
Oh, yes, ma'am. I'm just waiting for the students to take the links in the chat box.
All the feedback link, is it? Okay.
Yeah.
Feedback and other things.
Feedback and online test.
Yeah. Okay, Anu. Okay.
Yeah. Thank you,
Thank you,
Ram.
Ram sir.
Thank you, Ram.
Thank you.
Thank you, Anu.
I think Anu might have missed. Thank you, Ganapati. Thank you.